This is lesson 4.3, part 2. So let's summarize what we've seen so far. We've seen some interesting patterns. In the case where b is positive and c is also positive, for example, in question A over here, we had x squared plus 6x plus 9. And again, b is this term over here and c is this term over here. Where they're both positive, the two numbers we come up with, the two numbers that add together to give you b and that when you multiply them together give you c, they're both going to be positive. So they're both positive. I'm not going to write the entire word positive out. I'm just going to write plus here. They're both positive. For example, we got x plus 3 and x plus 3. In the case where b is negative and c is positive, so like example b over here, so we had x squared minus 10x plus 21. Both numbers were negative. Both were negative. So we got x minus 7 and then x minus 3. In the case where b is positive and c is negative, so I'll give an example. We didn't do one like that yet, but we have x squared plus 4x minus 21. You can try factoring that and seeing the pattern yourself. A number that when you add it gives you, two numbers when you add them they give you 4, and when you multiply them they give you 21. So let's try x minus 3 and x plus 7. So what you'll notice is one of them is positive and one of them is negative. The larger number, in this case 7, is going to be positive. Let's take a look at the case from example C where b is negative and c is negative. So where they're both negative. So for example, we had x squared minus 3x minus 10. One number is positive and one number is negative because we got x minus 5 and then x plus 2. What you'll notice is that it's kind of the reverse this time. You'll notice that the larger number, the 5 here, is the negative 1. The larger number is the negative 1. Larger is negative. So as you do your homework and as you do your problems, you should try to notice these patterns to make it a little bit more efficient for you when you're solving these problems on quizzes, tests, or other assessments. So now we're going to try a few more examples together where there's a few other steps involved here. Remember that we had skipped the common factor step because that wasn't required in the examples above. We could simply go find the sum of the product, the sum and the product and the two numbers, the factor properties to give us our factored form. In this case here, you'll notice that you could actually find a common factor between all three terms, take that out, and then you can proceed with the rest of the steps that we saw previously. So in this case here, let's start with A. You'll notice that there is a common factor you can take out. You can take out 2 from each of these terms here. If you do that, so we have 2 here. I can't take out 2y because the last term doesn't have y. I take out 2, and so when I do that, I do 2y2 divided by 2, which is y squared. Then minus y, and then minus 30. Like that. And now I can go and treat this this relation over here just like we did in the previous ones. So I'm going to go and write my two brackets here, y, y. I want to find the number so that when I add them together, or when I multiply them together, the product is negative 30. And when I add them together, the sum is negative 1. And so to do that, it seems like I could use negative 6 and positive 5, right? Because negative 6 times 5 is negative 30. Negative 6 plus 5 is negative 1. So we have negative 6 and positive 5. And then to verify, what you can do is you could go and you could expand this factored form to see if you get back to the form up here. So I'm going to show you how to do that very quickly. First, I'm going to do my expansion using FOIL of the brackets over here. So I'm going to leave my 2 on the outside for now. Y times y is y squared. And then y times 5 is plus 5y. And then minus 6 times y is minus 6y. And then minus 6 times 5 is minus 30. I'm going to clean that up. So I'm going to get 2 outside the brackets there. Y squared plus 5y minus 6y is minus y minus 30. And then I can go and distribute that 2 into the terms there through multiplication. So I get 2y squared, because 2 times y squared is 2y squared. 2 times negative y is negative 2y. And then 2 times negative 30 is negative 60. And I get back to my expanded form that I had above. So that means that I did a correct job in factoring. So now let's take a look at example B over here. You'll notice that we can take out some common terms. In this case, not necessarily a coefficient, but we can definitely take out an x from one of these, or from all of these. And at least just the x1. We can't take out an x2 because this doesn't have x2s, but we can take out an x1. So we'll do that. We'll factor out x from each term. And when we do that, we do x cubed divided by x, that's x squared, plus 5x squared divided by x, that's 5x, plus, so 4x divided by x is plus 4. So now you'll notice that we now have a nice, easy quadratic relation over here on the inside of this bracket to factor. And so you have to remember to rewrite your x, because that can't go away. If you take away your x, you're now changing the entire relation. So make sure that x is back there. We'll make our brackets over here. We have x, x, and then we have a number. So a number that has to, when you multiply it, gives you 4. So the product gives you 4 for C over here. And when you add them together, it gives you 5. So the sum gives you 5. So two numbers, when you multiply them together, they give you 4. When you add them together, they give you 5. And it seems like those two numbers are probably, the product would be 4 times 1. That gives you 4. And 4 plus 1 gives you 5. So 4 and 1 seem like the two numbers we're going to use. So we'll have x plus 4 and x plus 1. And so there we factored our polynomial over here. And again, if you want to verify, you'd simply expand with FOIL first and then distribute with whatever's left on the outside. So just to show you that very quickly, to verify, x, and then I'm going to do my expansion here. So x times x is x squared. And then x times 1 is plus x. And then 4 times x is plus 4x. And then 4 times 1 is plus 4. I'm going to clean that up a little bit, so we get x times x squared. X plus 4x is 5x, so plus 5x plus 4. And then I can go and distribute that x into each term through multiplication. So I get x times x squared, which is x cubed. X times plus 5x, which is plus 5x squared. So far we're looking like we're on the right path there. And then x times 4 there, that's plus 4x. And so we get back to the same expanded form that we saw earlier. So that means that we did the right steps in factoring. So You should go back and try these examples to make sure you understand how to do them, and then try other examples from your textbook. Before we end this lesson, we're going to do a quick example of sketching now that we know how to convert into factored forms. And we'll see how that's going to be useful in helping us to sketch a little bit more. So in our case over here, we have this quadratic relationship, y is equal to x squared minus 2x minus 24. And the first part of the question is asking us to write this standard form, take this standard form, and to convert it into the factored form. So we need to do some factoring here. And so remember that we want to find, this is our b over here, this is our c over here. We want to find two numbers that when you multiply them together you get negative 24. And when you add them together you get negative 2. So if you do negative 6 times 4, let's try that out, you get negative 24. And then if you do negative 6 plus 4, you get negative 2. So we found there are two numbers there. We're going to write this down as x minus 6. Y is equal to x minus 6. And I'm just going to do proper form here. It was a bit hard for me to do before, but let's make sure we line up our equal signs there. X is equal to x minus 6 times x plus 4. And if you want to, you could verify by doing FOIL to expand. But what I want you to get is that the reason we did this is because it allowed us to find our zeros. Remember that you want to find when y in a parabola is equal to 0. So you need to find when each of these terms will be equal to 0. So x minus 6 is going to be equal to 0 when x is equal to 6. So you're solving for x here, right? So when x is equal to 6, y will be 0. So that's one of your zeros, 6, 0. When your other zero is going to be when the other bracket's equal to 0. So x plus 4 is equal to 0. And if you solve for x, you'll see that that's true when x is equal to negative 4. So when x is equal to negative 4, y will also be equal to 0. So another 0 we have is negative 4, 0. And so that factored form gave us a great way to spot what our zeros are to help us sketch a parabola. We can also find the vertex. Now that we have our zeros, we know we can do the x of our vertex is going to be equal to s plus t divided by 2. Basically, there are two zeros added together and then divide them by 2. So x of our vertex is going to be equal to our 6 plus minus 4, because the vertex is in between the two zeros, divided by 2, which is equal to 2 over 2, which is equal to 1. So that means that our vertex has an x that's equal to 1. And then we can find the y by plugging in that x into any one of the forms of the equation, either the standard form or the factored form. I'm going to plug it into the standard form. So y is equal to 1 squared minus 2 times 1 minus 24. And we get 1 minus 2 minus 24, which is going to be equal to minus 1 minus 24, which is going to be equal to minus 25. So the coordinate of a vertex is 1 minus 25. So we have our zeros over here. We have our vertex over here. We can see that the a is positive in the standard form. Over here and also over here, it's positive. So that means that our parabola is going to open from the top. So knowing that information, we can go and sketch the graph in the next video.